Hello everyone, this is Mohammed and this is a new video tutorial and it's going to be about real-time clock of the STM32F4 Discovery board, and it's pretty much the same for other STM boards as well, as long as you use CubeMX and HAL libraries. So basically real-time clock allows you to measure time, date and use alarm functionalities, and that's what I'm going to walk you through today. And the way I'm going to go about doing this is that I'll first show you how to do this with CubeMX for people who want to implement things really quick, and towards the end of the video I'll walk you step by step through doing the same thing but without the help of CubeMX. Alright, let's start with CubeMX. So first click on New Project and select the right board, STM32F407 in my case, VGT. And on here we need to enable the real-time clock peripheral. So scroll down until you find RTC, here it is. Expand this, activate clock source and activate calendar. And I want to activate one alarm as well, so just an internal alarm without a pinout. That's it. So this one enabled real-time clock. As you can see in the clock configuration, RTC clock is enabled and low speed internal oscillator is selected. Well, the internal oscillator is not very accurate, so I would recommend that you use an external oscillator to get a very accurate clock. And what you need to do if you use an external oscillator, you need a tick of 32.768 kilohertz, and you connect this through PC 14 and 15 by enabling the low speed external clock. So if you enable this as a bypass or a ceramic resonator, will enable 14 and 15. But in my case I'm just using the internal clock, which as I said is not going to be very accurate, but you will see the seconds will take slightly faster than the normal seconds, but not very significantly. Alright, let's carry on. I'm going to enable a couple of LEDs before I carry on with the RTC configuration. So enabling the green and orange LED. Go to configuration window, click on RTC, and first thing we're going to set is the data format. I want to set the data in binary, just normal decimal number. So hours in 23, and by the way hour format to 24, I like it this way. Minutes to 59, so that I can see changing hour, seconds to 45. Daylight saving, we haven't got any daylight saving yet, but this is a quite good option for people who have winter or summer changing time. It's very cool. You can subtract 1 hour or can add 1 hour. Weekday, so this is the date. Weekday is let me select 31st of December of this year, which was Sunday, and the month to December, and date to 31st 2017. So that after 15 seconds it will change hour, and will change date, and it will change year, which is pretty cool because I can see this. Then alarm, I'm going to set the alarm to 0 hour, which corresponds to 12 minutes to 0 and seconds to 10 seconds. So when it changes day, I'm going to get an alarm after 10 seconds, and that the date is 1. So you can set the date here. It's going to be 1st of January, but the alarm can only be 1 month long. You cannot do an alarm for next month. It has to be within this month or within this week if you decided to do weekday alarm. Okay, perfect. So I think that's all we need. Oh no, hold on a second. I need to enable the alarm interrupt as well, so that it will interrupt on the alarm. And that's all for the RTC configuration. So click OK. And click on this icon to generate the source code. Give the project name, I'm going to call it RTC video. Select a location to store it in. I want to store it on my STM projects folder, and select the right IDE, Keil Macrovision 5 in my case, and hit OK. And once the project is generated, click on Open Project, and this will take you to Keil Macrovision IDE. And on here, expand the project folder and go Application User and open the main. And let's first have a look at the RTC initialization, just to double check, because I had issues with it in the past. So the RTC initialization set the hours format to 24, set the alarms, but it did not set the time and date, which is as I expected. So we need to do those manually. They're very short anyway. So first let me set the time To set the time, use the time type diff, which is this one, already defined by CubeMX. Others are very intuitive, so stime dot hours to 23, minutes to 59, because I want to see changing an hour, seconds to 45, just like what we tried to do in CubeMX, but it didn't do this for us. And then all you gotta do is to call RTC set time. So hal RTC set time, and this takes the RTC init type diff, which is defined here. So RTC handle type diff, rather HRTC, as a first parameter. Yeah, it takes this as a first parameter, a pointer to that. And the second parameter is the time type diff, which is this one, and it's a pointer to that. And the third parameter is the format. So this one is format binary. So because I'm just sending normal numbers, I can use BCD instead, but it's binary is much easier. Okay, so this is simply how to set time. Now let's set date. To set date, use the same principle. We need to use the date type diff, which is defined here as date. So sdate dot date is going to be 31st. Month is December, so 12. Oh, sorry, month not quite 12. You have to use the defined, so RTC month and control space to see the options, and it's December. Because if you look at December, I don't think the number is 12. I gotta compile first, but we'll have a look at it later. Then the weekday, same thing, so RTC weekday, and I'll give you the option. I think it was on a Sunday. Yeah. And the reason why I chose 31st of December is that I want to see changing month. So after 15 seconds, as I explained in CubeMX, date will turn to 1st of January, and day will change, and year as well will change. So last thing is to set year to 2017, but you shouldn't write 2000, just write 17, because this is a number between 0 and 100, I believe. And then finally we need to call the hal RTC set date function. Okay, so the first parameter is the same one, the RTC handle type diff, and then the date type diff, and a pointer to that. And last parameter is the same thing, the RTC format, and we're sending just normal binary numbers. Okay, so far so good. The next thing to do is to get the time and date in the while loop. So I'm going to read the time and date every 200 milliseconds, for example. And to get the time, use a function called hal RTC get time. And parameters are exactly the same as the set time one. So what it's going to do is that it's going to get the time and store it in that stime again, update the stime structure. And same thing for date as well. So hal RTC get date, and the parameters are similar to the date thing here. Okay, I'm also going to toggle an LED here. So my orange LED is on port D, pin number 13. So we got the time, we got date. One final thing we got to do is to define the event callback for alarm A. So when we get an alarm, it will jump into the event callback. And to define this, go to functions and search for RTC in here. And it's a function called alarm A event callback, this one. We just need to copy it to our main, but without this weak object. And in there we write our code if you want to handle the alarm. So on the alarm, I want to toggle an LED, my green LED. Green LED is on port D, pin number 12. So on the alarm, it will toggle that LED. Alright, I think we're ready. So yeah, we set time and date when we got time and date, and we have the alarm callback. So let's compile the code then. Okay, compiled successfully without any errors. Now let's load it to the board, and we're going to have a look at the variables in the Steam Studio. So good, load it to the board fine. Now open your Steam Studio. Here is our Steam Studio. I'm going to expand this first, and click on this to open the project. So click on this, and navigate to your project folder. Here's the one, RTC video. Go to MDK-ARM and RTC video again, and you need to load this .axf file. And I want to see the date and weekday, month, date and year, hours, minutes, seconds, and sub-seconds. And click import. and they're imported here. So highlight all of them, and right click send to variable viewer, and I want to see them in a table format. Here we go. Now all you need to do is to run this and restart your STM board. Okay, I can see that it started from 45, and I expect on 59 or 60 this one changes and year changes, and also this. Okay, perfect. So 2018, 1st of January, and weekday is Monday, I believe. And on 10, I expect, yeah, the green LED came on the alarm, which is 10 seconds of 1st of January, or just the next month. Alright, good. Okay, we got our real-time clock working, time, date, and alarm using CubeMX. If that's all you're looking for, you may stop the video here, but I'm going to carry on. I'll show you how to do this without CubeMX. And to do this without CubeMX, click on Project and hit New Microvision Project and select a location to store your files in. I'm going to store them in this new cube file. I'm going to call it RTC no cube and hit Save. And now we need to select our board, STM32F4 or 7 VGT in my case, and this one. And here we need to select the software components. First one is the Simsys core, and then device startup, and the cube framework. We need to enable the classic. This requires other software components. We can add them by hitting resolve, and then in the STM cube hull we need to include the RTC, so real-time clock, this one, and that's all we need. So click OK. When you go under project, you see Keil Microvision generated files for us, mainly the hull libraries, but we need to add a main manually. So right click on this, add a new item, so C file, and we need to call it main. And on our main, first thing we're going to do is to include the hull library header file. So STM32F4XX underscore hull.h. This will include the hull libraries to our project. And then we need to define our main function. So int main void, doesn't take any parameters, and then the infinite while loop at the end. First thing we need to do in the main is to call the hull initialization function to implement the basic initializations. So it's called hull init. It's going to set everything to their default value. Okay, so we're going to add a few functions. The first one is the system clock configuration. So we need to configure the clock to enable the low speed internal clock for the real-time clock. And the way I'm going to do this, I'm going to copy the configurations over from CubeMX, but I'm going to include them down in the video as well in a text file. So let's define the system clock configuration function at the bottom here. So I copied it over from CubeMX, but the configurations are self-explanatory. So we're setting up the internal oscillator, the high-speed one, to 16 MHz, and then we enabling the CPU and APB and HBB buses, so the peripheral and timers clock, and then enabling the internal low-speed oscillator for the real-time clock, and then the SysTick interrupt to enabling that. Okay. And the next function we're going to add is the LED config to configure our LEDs. And this is so simple. You've seen it, I'm sure you've seen it 100 times if you watch my previous videos. So I'm going to define it at the bottom here. It's very simple. So you enable port D clock, because this is the port where LEDs are connected to, and you enable pin 12, 13, 14 and 15 for the green, orange, red and blue LEDs. The mode to output push-pull, and you call this init function to initialize those pinouts. And next we're going to add a function to configure the real-time clock. We call it RTC config. So definition of this function, first thing we're going to do is to enable RTC clock using this function, similar to the GPIO one, but this one is only RTC clock. So hull RTC enable. And then to configure the RTC, we need first to define an RTC handle type diff, and we're going to define it globally because we're going to need it in the main. So an RTC handle type diff, and I'm going to call it my RTC handle, and we'll use it at the bottom to configure the RTC. So the first one we're going to set is instance to RTC, and then we're going to do a few initializations. So .init hours format to 24. To 24 you can have 12 AM and PM, but we're using 24. And next is the asynchronous and synchronous clock dividers. So asynchronous prescaler divider is. This one is explained in details in the datasheet. So let me add the other one too. The synchronous prescaler or divider. So these are explained in details in the reference manual on page 785. So these synchronous and asynchronous prescalers are to create 1 Hz clock for the calendar. So since we have 32.76 kHz, we need to have the asynchronous one to 128 and the synchronous divider to 256. You can read more in here to get more idea as well. But this one starts from 0, so this one is going to be 127, 0 to 127, this one is 0 to 255. And next is the output. So output is disabled, so RTC output to disable, because we don't have any physical output, just an internal RTC. And finally we're going to call hull RTC init to implement those initializations. And this one takes only a single parameter, the RTC handle, and a pointer to that. And next on here we need to configure the alarm, and to do this we need to define an alarm type diff as well, and we'll define it globally too. So alarm type diff, I'm going to call it my alarm, and we'll use it to configure the alarm. So first is the alarm, and we're using alarm A. Then the alarm time, so alarm time dot hours are going to be 0 because 12, then minutes to 0 as well, and seconds to 10 seconds. And then we're going to specify the alarm date or weekday. So this one allows you to select between either you want an alarm on the weekday or the date. I want it to be based on date, not weekday, so date is and then I can set the value of this. So my alarm dot date weekday, not select, but the other one to set the value, and the value is going to be 1 because 1st of January, 1st of the month. Because if you recall from what we did in CubeMX, we set the 1st to 31st of December, and after 15 seconds it will jump into the 1st of January. So I'm basing my alarm based on 1st of the month. But if I select it weekday, then I'll have to select either as Monday, Tuesday, whatever. Okay? Hope you got the idea. And finally, we need to call RTC set alarm to implement those configuration for the alarm. And we need to set alarm as interrupt because we need to enable an interrupt on the alarm. The parameter we need to pass are the RTC handle type diff. So we need to pass this one here as a pointer. Next parameter is the RTC alarm type diff, pointer to that too, and the format, so RTC format to binary. And finally here on this function we need to enable the alarm interrupt and set its priority using these two functions. And out here, outside the function, we need to define the RTC alarm RRQ handler to link the system interrupt to the RTC to hull library RTC interrupt. And we need to do the same for the sysdig interrupt as well. These are usually defined by CubeMX in a file called stm.it file, I believe. And the reason why we need to do this is because the system in the startup file is programmed to jump into these interrupt handler, not the hull library one. We do these to link the two together. Okay, we're done with our configuration, so let's go and write our main. So on the main, I need to call in the functions I set up. So I need to call the system clock configuration function to implement its code, and same for the LED config and RTC config functions. I need to call them in the main. Alright, now we are on the same stage as a project generated by CubeMX. So let me copy the code over we did in CubeMX. So we set the time and date, and these require type diffs I need to define here for date and time. So I defined those. And I need to correct the name of the RTC handle type diff because we called it differently here. So I need to change it in here. And the get time date and the infinite while loop. So similarly I need to change the handle type diff name too. And finally I need to define the alarm RTC, the RTC alarm event callback function. Alright, so I'm going to put this down in the description and in a text file if you think I'm going really fast in here. But all I'm doing now is to copy the stuff I did in CubeMX over to here. Alright, I think we're done. So we set the time to 23:59 and 45 seconds and the date to 31st of December on a Sunday, and the year was 2017. Okay, and here we get the time and date. So let's compile the code. Alright, great, compiled without any errors. Next, before we load it to the board, we need to select the right debugger. So click on Options for Target, go to Debug, and select ST-Link Debugger. And also go to Setting, Trace, set the core clock to 16 MHz, and enable Trace and click OK. And now load it to the board. Alright, loaded successfully. Now let's go to STM Studio and watch the time and date. Here is STM Studio. I'm going to expand this first, and then click on this to load your project, this one. And navigate to your project folder and go to Objects. So this is the one done without CubeMX. The AXF file is stored under Objects. So, and select the AXF file. And I want to watch the time in hours, minutes, seconds, and sub-seconds, and the date in week, day, month, date, and year, and click Import. Okay, they've been imported successfully, so highlight all of them, right-click and send to variable viewer, and I want to see them in a table again. So all you need to do is to click Run and reset your STM board. Alright, great, I can see the time is working. Yeah, let's just wait until I get to 59 or 60. You should see the time changes in the year and the date too. Alright, fantastic, this is working. And on the seconds 10, I expect my green LED to come on. I'm looking at my board now. Yeah, it did, so perfect, we're done. Alright, this brings me to the end of my video. I've shown you today how to use real-time clock on the STM board with and without CubeMX. And as always, if you found this helpful, don't forget to hit like and subscribe. Have a nice day, and I'll see you next time. Bye.